Hello students. In today's class we will discuss about the hydraulic conductivity. So what is hydraulic conductivity? So a medium, it will have a unit hydraulic conductivity if it will transmit in unit time a unit volume of groundwater at a prevailing kinematic viscosity through a cross section of unit area, and that is measured at right angle to the direction of the flow under a unit hydraulic gradient. That is called as the hydraulic conductivity. So for practical works in groundwater hydrology, where water is a prevailing fluid, the hydraulic conductivity plays a very important role. So if you want to write in terms of formula, the hydraulic conductivity symbol is K, and that is given as minus V by dH upon dL. So the unit for this hydraulic conductivity is meter per day. So what is hydraulic conductivity in general? It is a medium will have a unit hydraulic conductivity. When it will have a unit hydraulic conductivity, if it will transmit in unit time a unit volume of groundwater. So suppose 1 centimeter if you are taking, then area, okay, so in it will transmit the material or the medium, it will transmit in unit time a unit volume of groundwater at a prevailing kinematic viscosity through a cross section of unit area, and that is measured at right angles to the direction of the flow under a unit hydraulic gradient. That is called as the hydraulic conductivity. Now to understand it in a better way, we'll see. So the unit for this is same as velocity, that is meter per day. So how to determine this hydraulic conductivity? Okay, of an aquifer. So although the hydraulic conductivity that is K is measured in a saturated zone, can be determined by a variety of techniques, including lot many calculations from the formulas. Then there are laboratory methods, and even the field methods are involved to determine the hydraulic conductivity of the aquifer. So in general, the field methods are more reliable than the laboratory methods. So we'll discuss all these methods to determine the hydraulic conductivity of an aquifer. So among the field methods, the pumping test is the most reliable and standard method for determining the hydraulic conductivity and the other hydraulic parameters of the aquifer system. So the laboratory methods, they include the permeameter method. There are two types of permeameter. One is constant head permeameter and other one is falling head permeameter. So these are the laboratory methods to determine the hydraulic conductivity. What is that? Constant head and falling head permeameter method. So that will give you the hydraulic conductivity, but it is determined in the lab. So it is laboratory method. And even the grain size analysis method is also applied to determine the hydraulic conductivity. Then the field methods include again various methods, like you can use some tracers, okay, that is called as tracer test, then auger hole method, sludge test, pumping test. These are called as field test. They are performed in the field actually, okay. So in a well, if you want to find out the hydraulic conductivity, you have to select a specific well and you have to do the testing on that. Okay, so there are different methods like tracer test, auger hole method, sludge test and pumping test. So these are the field methods which are applied to determine the hydraulic conductivity of the aquifer. Now let us discuss one by one all the methods. So first one is formula method. So there is a predefined formula. So numerous investigators, they have studied the relationship of the permeability or the hydraulic conductivity to the properties of the porous media. Okay, and several formulas have resulted based on the analytical or experimental work, and most of the permeability formulas, they have a general form, that is K is equal to CD square, where C is what? C is the dimensionless coefficient. Okay. Or the K is also written as K is equal to Fs, F alpha and D square. So what is this Fs, F alpha and D square? So Fs is the grain or the pore shape factor. So these are all the factors. Okay. So Fs is the grain size or grain shape factor. F alpha is the porosity factor, and D is the characteristic grain diameter of the grain, and Fs is the pore shape factor, means in between the particles. Okay, suppose these are the grains which are well rounded, or sometimes they may be angular. Okay, so Fs is what? Fs is the grain or the pore shape factor. So what is the shape of that? That is a factor for that. So that is a grain shape factor. Then porosity factor. How much is the porosity? N is what is the porosity? N is equal to volume of voids, okay, divided by total volume of the aquifer, that is the porosity. So porosity factor, and D is the characteristic grain diameter of these grains. So this is the general formula by which you can determine the hydraulic conductivity. Then we'll move on to the next method, that includes the laboratory method. So in the laboratory, the hydraulic conductivity of undisturbed geological samples or the soil samples, that can be determined in the laboratory by a permeameter. A permeameter is an instrument which is used in the lab to determine the hydraulic conductivity of the sample. So it is undisturbed geological sample. It may be any type of rock or a soil sample, and of which we have to determine the hydraulic conductivity. So the types or the permeameters, simple to operate and they are widely used. So there are two types. One is constant head permeameter and other one is falling head permeameter. So what is that? Constant head permeameter. So in constant head permeameter, the flow which is here in the figure, you can see there is a continuous supply of water from the top, you can see, and this is the sample which is under observation. Okay, and here there is a continuous supply of water, and there will be discharge of water from the other end. So here the constant level of water is maintained in this tank, right? So it is called as constant head permeameter, because the head or the water level in the water level is maintained constant. There is a continuous supply of water which will maintain the constant water head. Okay, and if it is excess, it will overflow from this end, right? So the level in the water, this overhead tank, that remains constant always. Okay, so it is called as constant head permeameter. And there is a sample, okay, whose length is L. Here you can see it is L. Okay, and here whatever volume of water is collected in time t, you can measure. Okay, Then this shows the horizontal area of the sample, that is A, and there is a porous plate which is included in between the sample. Okay. So here what is done in this method, we'll see. So in this method the flow is maintained through the small sample. Flow is maintained constantly, okay, through a small sample of the material, while the measurements of the flow rate and the head, okay, are made, and the constant head and falling head type of permeameter are simple to operate and they are widely employed. So what is done in constant head, we'll see now. So in this method, this method can measure the hydraulic conductivity of consolidated and the unconsolidated material under the low head. So here you can measure the hydraulic conductivity of both. It may be a consolidated or it may be a unconsolidated. What is the meaning of unconsolidated and consolidated? Consolidated will be hard, okay, hard, which is like a rock, okay, and unconsolidated will be loose, okay, loose sediments like sand, okay, which are loose, they are not compacted, so it is called as unconsolidated formation. So under the low heads you can determine the hydraulic conductivity. So the water that enters the medium of the sample of the earth material in the cylinder from the bottom and is collected as overflow after passing upward. Okay, so here what happens, the water is moving down from the pipe, and how it is entering into the sample from the bottom, okay, and it will flow through this sample, and whatever water is coming up, okay, it is moving up, that is collecting separately, that is collected separately. So here the water or the water, it will enter the medium of the sample of the earth material in the cylinder. So here this is a cylinder and the water is entering from the bottom, okay, and it is collected as overflow after passing upward, okay, from upward from the sample. So this is done in constant head permeameter. So we know from Darcy's law, right? What is Darcy's law? We have discussed. So in this case, K is given by, okay, so Q, first we know from Darcy's law where we can find out the K. So Q is equal to, Q is the discharge. Discharge is what? Volume divided by time, okay, V by T. So this can be written as, from Darcy's law, this Q can be written as KIA, okay, where you can replace this I as K into H by L, okay, and A remains as it is. Then the K, you can write it as this H by L, so volume by time into H by L. So the final formula for finding out the constant head permeameter from Darcy's law, we got it as VL divided by ATH. Okay, so that is the formula to find out the hydraulic conductivity of the material for the constant head permeameter. So where V indicates what? V is the volume of water which is discharging in time t. Okay, then L is the length of the sample. Okay, then A is the cross section area of the sample, then H is the hydraulic head, and K is the hydraulic conductivity. So K we can find out with the help of formula, that is VL by ATH. Okay, so this is from Darcy's law, we got the final equation. So this is how we determine the constant head permeameter. Okay, with the help of that we can find out the hydraulic conductivity of the sample which is under observation. Then we'll see what is done in falling head permeameter method. So in this method, the the water is added to the tall tube. So here you can see there is again a tall tube. Water is entering from this tube into the sample. Okay, but here the head is not maintained constantly. It is a falling head permeameter. So as the water moves, the water level in the tube also goes down. So here you can see the initial height of the water, that is h1. Then after some time the water will go down, that is called as h2. So here there are two parameters, h1 and h2. Okay, and these are again the porous plates, and this is the sample. Then this is the length of the sample. Okay, and whatever water is overflown, that is collected here. Okay, so here in this method the water is added to the tall tube, that and it flows upward through the cylindrical sample, and it is collected as overflow. Okay, the test consists of measuring of the rate of fall of the water level in the tube. So what we have to measure here? Rate of fall of the water level in the tube. So the hydraulic conductivity can be obtained by noting that the flow rate Q in the tube, that is the hydraulic conductivity, can be obtained by this formula, that is K is equal to 2.303 A into L divided by 80 into log to the base 10 H1 by H2. So this is the formula to find out the hydraulic conductivity for a falling head permeameter method. So where K stands for the hydraulic conductivity of the material. Then what is that small a? Small a is the cross section area of the tube. So this is the a cross section area of the tube, that is called as the small a, and L is the length of the sample material. Then capital A is what? The cross section area of the sample in the cylinder, whereas small a is the cross section area of the tube. Okay, and H1 and H2 are the initial and final head of the water in the tube. Okay, and T is the time interval. So this is the formula to find out the falling head, the hydraulic conductivity with the help of falling head permeameter. Then what are the disadvantages and advantages of this falling head and constant head permeameter? So disadvantages of these laboratory methods are the undisturbed sample of unconsolidated material, they are difficult to obtain, because when you take the sample from the earth, right, obviously it will undergo at least some disturbance. So the undisturbed sample, getting the undisturbed sample is very difficult, while the disturbed sample experiment, sometimes the changes in the porosity or packing of the grains. Okay, so there may be chances of error, okay, for the actual reading. Then the flow direction properties of K may not be recognized. So these are the disadvantages of the laboratory method. And what are the advantages of laboratory method? It is cost effective method. Then the labor requirement is less. Okay, and it is easy method for the determination of hydraulic conductivity. So other methods of determining hydraulic conductivity we will discuss in the next class. Thank you.